Today we're going to be discussing Newton's second law. So what is Newton's second law? Newton's second law is the sum of forces. So this is a Greek letter called sigma, and it represents sum in math or any science. And the F represents force in a direction, and that equals the mass of the object the forces are acting on, and the acceleration that the object is taking. So, how can we use our prior knowledge of position, velocity, and acceleration to connect to forces? So remember, position to velocity, which is a vector, which means it has speed and the direction, positive or negative. Usually right, up, and forward is positive, and the opposite to those are the negatives. So we get from position to velocity by figuring out what the change in position is, and we get from velocity to acceleration by figuring out what the change of velocity is. So, which is also the slope of the graph, if you remember from that video. So now, if we have the acceleration, and we also have the mass, we are given the mass of the object, we can calculate the sum of forces in the direction. So why does this only work in a direction? So what if an object had a force acting up, down, right, and left? So now we'd have to separate these forces into directions. So this left and right direction would be sum of Fx, so in the x direction, equals mass, which would stay the same for both of these, times acceleration in the x direction, and this would be F of the y direction equals mass times acceleration in the y direction. Okay, so now let's talk about balanced and unbalanced forces. So what are balanced and unbalanced forces? So if an object has, let's say this box, has the same equal forces acting opposite of each other, and forces come from the middle of the object. So let's say this force and this force are the same. That means the object has a constant velocity, and the constant velocity can be 0. So if the object is already still and the forces are balanced, that means the object will not move or will not accelerate. And if the object is already in motion, then the object will move at a constant velocity, which means it'll still have no acceleration, but it will move at the same speed and direction that we already know. However, unbalanced forces means that one force is greater than the other force. So we can tell that the force going right would be greater than the force going left. So if the object, that means the object is going to accelerate in the right direction. So because there's a higher force acting on this. So how do we know this? We can calculate this by doing the sum of forces. The sum of forces can just be calculated by adding or subtracting the right side and the left side. So we already know that this is, let's just call it x, and this part is also x, so we get 0. That's our acceleration. However, here we're gonna have, let's call the big line 3x, the small one x. We're gonna have a force of 2x. So that means, since it's positive, we know it's going right, and since there is a force greater than 0, that means we know the object is accelerating by that much. So if we're giving the mass, we can figure out what the acceleration is too. Okay, so now let's look at this box on this flat ground. So we know that gravity exists. So what would be a rewritten form of gravity of Newton's second law? So we'd write that as F sub g equals mass times gravitational acceleration, or acceleration due to gravity. So this g is just a replacement for whatever the acceleration due to gravity is on whatever planet or space you're in. So on Earth, g is going to equal 9.8 meters per second squared, or 9.81 to be a little more precise. And if you're talking about directions, you can also include a negative. So why is this significant? This is significant because if a basketball, say this big ball, and a little paper ball were dropped from the same height, so let's say this ball was dropped from the same height and they both landed on the ground, which one do you think is going to land faster? If you said both would land at the same time, then you're right, because acceleration doesn't change. Even though the force is going to change, because the ball is going to have a greater mass and in turn have a greater force, that does not change the acceleration, nor does it change the time it takes for the objects to reach the floor. Okay, now let's look at this box. We know that there is a force of gravity because there's always a force of gravity no matter where you are, unless there is no gravity. And the gravity is always going to act downward. And remember, forces act from the center of an object. So we're going to label that as F of g. Now, it looks like there's an unbalanced force here, which means the object would accelerate through the floor, which we know is not true. So what other force is acting on this object? We call it the normal force. So the normal force is what keeps the object from accelerating, and it's not always equal to the force of gravity. So but in this case, since we know the object is not accelerating at all, there's a normal force acting on the object by the ground. So the normal force is actually not always the same, going the opposite direction of the force of gravity. Since this is a flat ground, the normal force is always perpendicular to whatever the ground is. And the ground is at 180 degrees, we're going to call it, or 0 degrees, and the normal force would be at 90 degrees. Okay, so now, what if the object were on an incline? So now, the same box, so we always know that the force of gravity is gonna act downward, no matter what. However, notice how the object is on a slanted surface. That means the normal force is going to be perpendicular to the surface, not the opposite direction of the gravity. And if we know that the object is not accelerating in the y direction, we know that the component of F normal force is equal to force of gravity.